spaceship, a space robot, or a space satellite. That's wonderful. So I believe that in the future, we need billions of people building space technology. And today, I want to share with you why I think that is true and how we can do it. And to do that, I want to start by sharing you with my own story and how this belief developed. So this is my hometown. It's a very small town in California on the coastline. Only 2,000 people lived there. And in that town, I could look up and see the Milky Way and all of the stars. And when I was little, I had big questions. What is our universe? What is space? What is time? What is gravity? In addition, my neighbor, he was the assistant of a man named Dr. Robert Goddard. Dr. Goddard and his wife invented the first rockets in the United States. They did this during the Great Depression, mainly in the 1920s. They had very little money, but they had big dreams, and they helped create this new industry. Hearing this when I was a child made me realize that we can all do great things in our lives. Also, my grandfather, he worked on the Apollo missions, and he invented something called the high gain antenna. This antenna, it transferred the television, the signal when we landed on the moon and the humans took their first step, it transferred that video back to Earth so everybody could watch it. And so I grew up hearing the story of how everyone could witness and participate as we explored space. So there were two things that defined me. One, in this small town, I felt very close to people and had a lot of empathy and cared a great deal for the other people in my town. But I also had these very big dreams and big questions and wanted to understand space. I wasn't sure in my career how to combine both of them. But I went into Stanford when I was 19 to study physics and wanted to study the universe. But during my first year, I had a lot of trouble with the math. And so I switched my major to international relations and history. And I went to Vietnam when I was my first year to work there in Hanoi. And while I was there, it really shaped my worldview, and I learned many things about the world. First, I realized that the people my age in Vietnam, we were very similar. We had very different pasts. Our histories were different. Our economies were different. Our governments were different. Our parents, our grandparents' generations were very, very different. But the people I met, I realized we had the same future. We wanted to have the same jobs. We listened to the same music. We cared about the same sports. So I connected to my generation around the world during that experience. At the same time, when I was in Vietnam, I noticed how many of the people that I met were extremely smart, but they did not have a job because of the economy. And this stayed with me, and because I cared a lot about how do people express their potential. And from that, I decided to take the rest of my career in the nonprofit sector. I worked for an organization for about 10 years called Ashoka. And Ashoka works in hundreds of countries around the world supporting social entrepreneurs. So people around the world who are solving social problems. We had 4,000 people that we worked with. And while I love that job, and while I learned so much, I kept thinking about my questions about space and thought, I'm happy helping make the world a better place, but what about the space industry? And what about all those questions that I had as a child? So one day, I came across on the internet a place called Singularity University. And this was a new university located at NASA in Silicon Valley. And their goal was, how do you take technology and use it to solve social problems? And I felt those two parts of me could come together into one career. So I applied to their university and did their 10-week program there in 2011. Singularity University is based on the belief about exponential technologies. Who's heard of exponential technology? Great, great. So an exponential technology is one that rapidly becomes more powerful and more efficient and more sophisticated while the cost goes down very rapidly. So our cell phones, our computers, we all have seen this. They become more and more and more powerful and sophisticated while the cost goes down. And this exponential technology, it means if you create a product or a service with it, it can scale to billions of people very quickly. So we know this is true for our cell phones and our computers, but it's also true for anything that is information-based, this trend. So this means it is true for software, for artificial intelligence, for robotics. Now that our DNA is a code, is information, it's true for biotechnology, it's true for 3D printing, nanotechnology, digital fabrication. So as we bring computers and software into everything around the world, it will follow these same trends. Just like the computer became very inexpensive while becoming more powerful, in a few years, we will all have robots. We will all have artificial intelligence. We will follow these same trends. When I was at Singularity University, we have team projects that we create, that we turn into companies or nonprofit organizations. And in 2011, I was on a team that created the first use of a small drone for transportation. Our idea was to use the drone in the developing world, in places like Africa, where there are no roads, and people have to walk a long ways to go to the hospital. So we thought we can send by drone the blood test or the medicine. So this company succeeded, and it now exists. And now there are also hundreds of other companies that are doing similar things. It's an $80 billion industry now. This drone is just, a few $100s, so it's also following that exponential curve. So from this experience, I learned the power of exponential technologies and how to start a company. But still, I kept thinking about space and my childhood dreams, and what about those? And while I was at Singularity University, I also realized that space technology is an exponential technology. So rockets, satellites, robots, they're all computers, software, sensors. And so the space industry will follow the same curve. The space technology will rapidly go down in cost while becoming more powerful. This is the global space industry since 1950. It's just the commercial side of it. And it's now worth $314 billion. So that is more than the world's microchip industry. I also realized when I was looking at the space industry, at least in the US, the entrepreneurs in the new space industry are the internet billionaires. So Richard Branson, Elon Musk, Jeff Bezos of Amazon, Paul Allen of Microsoft, they made a lot of money during the internet industry, and now they are launching space companies. And while I'm very excited that we have a private space industry now, I started to worry about who will own this industry. Will it be the world's billionaires, only the wealthiest people? When we think about space, we often just think of sending, rockets, but not really that it's a future industry. So there's the communication industry, the satellites, but it's much more than our cell phones and our television signals. It's now part of the Internet of Things. There's cameras, there's data. The satellites will connect to the drones, to the robotic cars, to this whole system. And there's companies that are now working on manufacturing in space. So this is going to be a huge business, and it's the future of humanity here. So with the exponential technologies, it's also changing the sorts of companies that we have in the world. Because initially when you build an exponential technology, it's very expensive. a robot or artificial intelligence, the first people who build that costs a lot of money, but then it goes down rapidly in costs. And so in the US, we're starting to see 3 different types of companies emerge. So one, you have very big companies that are able to create these new technologies and in many different industries, but the founders are keeping most of the profit for themselves. So they build the company, they charge a lot for the products and services, they pay the employees very, very little, and then they keep everything for themselves. So they're creating new products and services, but they're not really helping society. In some ways, they're even creating poverty. You also have a second type of company, and this company is also big, and they create new products and services, and the founders become billionaires, but they give out stock to their employees, and they pay their employees well, and they all become millionaires, and then they go and create more companies. And these companies also give out philanthropy, and they contribute, so they keep the society stable, and these are very important. And this is much of what makes the Silicon Valley work, is these types of companies. The third, because of the exponential technologies, also they're very powerful when they start to go down in cost. Anyone can use them. You have a lot of startups starting to build new companies. And they're using things like crowdfunding, or crowdsourcing. And they're sharing the costs and also distributing the profits in a more fair way. These are my favorite types of companies because not only are they helping the society grow, but they're unlocking innovation because they're allowing everybody to contribute. And this is how I think we need a future space company. So I saw these trends happening around me, and I also remembered when I was in Vietnam, saw all that talent out there in the world where there was nowhere for those people to work, where there was no economy. And I thought about the new space industry, and right now we should be building space companies that everybody can participate in all around the world so that they can benefit in the future. And so I asked myself a question. So what if I could use technology to harness all this talent around the world to collaboratively build space technology, and then to sell it and distribute the profits in a fair way? And this could lower the costs of building the space technology and unlock innovation, and also create a space industry that everyone can participate in the future. So in 2013, I incorporated a company, and I ran a competition on the internet. I found a sponsor to put up a $10,000 prize. 3 prizes, $5,000, $2,500, $2,500, to see if anyone in the world could design a 3D printed rocket engine. It was a very difficult technology at that time, so it was a real challenge. And the rocket engine would have to carry 1 kilogram to low Earth orbit, so it was a challenge. People would need to submit their designs and a business case. And then I had professional judges from the space industry judge the best teams. So what happened? Over 80 teams signed up from around the world. This was very little advertising on my part. In fact, I think this whole effort, I spent maybe $2,000 to run this myself. So 80 teams signed up from around the world, from countries India, Europe, United States, Canada, and many different ages. There were professional people with space companies, there were college students, and there were even 4 teenage girls that entered the competition. So the winners were from the University of Victoria, and as soon as we announced the winners of the competition, they were immediately hired by Boeing and another company called Rocket Lab. So this was evidence that we could bring talent together that was important. The second place winners were UC San Diego, and they created the injector plate of their engine with a 3D printer. And they decided that they were actually going to go on and to print a bigger engine. They've been testing this in the California desert. The third place team this is their engine here. The design was not the best, but it was very interesting because they had 7,000 people on Facebook contribute to the design, and every week they would hold a Google Hangout. So they demonstrated that you could have radical collaboration in the space industry. So we learned things. This was an experiment. So we learned that the talent exists, the desire to collaborate exists all around the world. We learned that small prizes work. So for $10,000, we had 10 people submit all of their design materials. In a big space company, it usually costs $12 to $14 million for that design stage, and it usually takes 1 to 2 years, and our competition was for 4 months. So there are more professional people at the big companies, but we think this demonstrated that we have the potential to operate in this way. We also learned that you can have radical types of innovation with space technology. There were some challenges. At the time, the software that allowed engineers to collaborate was not very good. Also, 3D printing capabilities were very early for rocket engines. That is continuing to improve a lot. Next, also, we did the design part of developing the space technology, but to build it and to test it and to manufacture it, that part is very, very expensive. And then finally, in the last year, there's a new type of design that has come about called generative design. And this is where you have artificial intelligence designing space technology. So I wonder, will we need people in the future to be designing space technology if computers can do it? So that is what we learned. Right now, we are identifying our next contests that we will hold in the future to build more types of technology. We're continuing to look at space transport, space robotics, space communications, and also space biotechnology, which is very important if we will have humans in space. So thank you very much. I hope that you will all join us in the future in building space technology, or that you will also go out and start your own space company. Thank you.